Good morning, Year 5. I hope you're all well. Today is Lesson 12 and we will be comparing mixed number fractions. So first of all, what is a mixed number fraction? Well, a mixed number fraction is where you have whole numbers, integers, and a fraction. So in this case, we can see we have 1 and 7/8. Here is my integer and this is my fraction. Another one would be 2.5. Here is my integer and this is my fraction. So to begin with, we're going to look at some nice simple comparisons. First one is where we have the same denominator. So here we have 1 and 7/8 and 1 and 5/8, and we want to compare them. We notice straight away that the whole numbers, the integers, are the same. So we can move on and ignore that. And in fact, we're just going to look at the fraction part of this problem. We know that denominators are the same. They're both eighths. So that means we must straight away look at the numerator. We notice that 7 is larger than 5. So because we have the same whole number, integer, I know that 1 and 7/8 has to be larger than 1 and 5/8. It's greater than. So I would write it like this. 1 and 7/8 is greater than 1 and 5/8. So that's a nice straightforward one. Another really straightforward one is where we actually have different whole numbers or different integers. So in this case, we look at this problem, 2.5 and 4 and 7/10. We look at our integers and we notice that they are different. So this time I know that 4 is a larger number, whole number, than 2. So I don't even need to look at the fraction part of this problem. I know straight away, because we've got different whole numbers, different integers, that 4 and 7/10 is greater than 2.5, or 2.5 is less than 4 and 7/10. And I would write it like this. 2 and 1/2 is less than 4 and 7/10. So those two examples are nice and simple and straightforward. Ones that have the same denominator and ones that have different whole numbers. So our main focus today is going to be where we look at mixed number fractions where we have different denominators. So in this problem, you can see we have 1 and 2/3, and we're comparing that to 1 and 5/6. We notice that our whole numbers, our integers, are the same, both are 1, but we do notice that our denominators are different. Now, if I was going to represent this as we did yesterday, and I was going to use my fraction strips or my fraction bars, I would need to create them using a ruler. I can obviously draw these in my book. The ones I have created, I have cut out just so I can model it to you. But for you, you would be drawing these in your books. The strips must be the same length so that they can equally represent the fractions that you are putting into them. So for the first one will be 1 and 2/3. So I know that my whole is being split into 3 parts. And I know I have 1 whole. And I know I have 2/3 for the second part. So I have 1 and 2/3, and that's how I would represent it using my fraction strip. I now have to compare it to 1 and 5/6. We know I have 6, so I have 1 whole and 5/6. So to represent the whole, I can show it like that. I've still split it into 6, but it's 1 whole. And for the second part, I have 5/6. I'll place it on like that. And immediately you can see that 1 and 5/6, when it's visually represented, is a larger mixed number fraction than 1 and 2/3. I would then write it as follows. I would say that 1 and 2/3 is less than 1 and 5/6. If I'm confident with my fractions and I feel that I don't need to use fraction strips, I can actually then go on and compare my mixed fractions by using my common denominators, by finding my common denominators, excuse me. So first of all, we look at this and we have 1 and 2/3 and 1 and 5/6. If I look at the fraction part of these problems, because I have equal integers, I only need to look at the fraction part. I see that I have 2/3 and 5/6. So I need to think about what is my common denominator. If I look at 3 and 6 in my denominator, I know that they are multiples of 3. I know that if I multiply 3 by 2, it will give me 6. So that's what I'm going to do. I'm going to change 2/3 into 6 by multiplying by 2, both the numerator and the denominator. So 3 times 2 is 6, and now as my 6, 2 times 2 is 4. So I know that 2/3 is equal to 4/6. I can now write this out again. So I have 1 and 4/6, and you have 1 and 5/6. My integers are the same, so I can ignore them. I need to look at the fraction part only, and I know that 5/6 is larger than 4/6, or 4/6 is smaller, than 5/6. So I need to say that 1 in 4/6 is less than 1 in 5/6, and I would write it like that. So we come up with the same answer as here, except we have found an equivalent fraction for 1 and 2/3, 1 and 4/6. So here I have another example. I have to compare 1 and 3/4, a mixed number fraction, and 1 and 5/8. So the first method is to create my fraction strips. I have 1 whole and 3/4, so I represent my 1 whole, and then I represent my 3/4. They're all of equal length and size. 1 whole and my 1, 2, 3/4. I then need to represent my 1 and 5/8. I have my 1 whole, and I have my 5/8. And once I place these underneath each other, you will of course draw them in your books. You can see visually that 1 and 3/4 is greater than 1 and 5/8. I would then write this as follows: 1 and 3/4 is greater than 1 and 5/8. I can also solve this using my common denominators. If I look at the problem of comparing 1 and 3/4 and 1 and 5/8, I notice that my integers are the same, so I will be focusing on my fraction part of my mixed number only. If I look at my denominators 4 and 8, I will recognize using my times table knowledge that both are multiples of 4, and that 4 will divide into 8 2 times. I will take my 3/4 and I will multiply it by 2 to turn it into 8s. 4 times 2 is 8. 3 times 2 is 6. I will now rewrite my problem, 1 and 6/8. So I have my equivalent fraction in there, and 1 and 5/8. And I can see that my integers are the same, so I go straight to my fraction part of my mixed number, and I know that 6/8 is larger than 5/8. So I can say that 1 and 6/8 is greater than 1 and 5/8. And I put in my symbol. So now it's your turn. I would like you to pause the video and solve and compare this mixed number fraction problem. We have 2 and 3/5 and 2 and 7/10. I'd like you to solve it using the two methods I've shown you. First of all, I'd like you to draw your fraction strips using a ruler, and then I would like you to find the common denominator to compare the two mixed fractions. So I'm hoping that when you were trying to solve this, you noticed that the integers in both the mixed number fractions are the same, and in this case they're actually slightly larger than the ones we've done before. They're both 2, so we have 2 whole numbers. So if you were creating 2 and 3/5, you know that you need to have 2 whole numbers. So this is 1 whole number, and then we create another whole number, and then we need our 3/5. So we create our last part of the mixed number. We have 2 whole numbers and 3/5. We now need to create 2 whole numbers for our 2 and 7/10. And we create our second whole number. We have 2 whole ones. And finally, we need our 7/10. So looking at this visually, you can see that 2 and 7/10 is just slightly larger, slightly greater than 2 and 3/5. So if I was to write this now, rewrite it, I would have 2 3/5, and I would have 2 7/10. And I know that now that 2 3/5 is less than 2 7/10, and I would write it out like this. The second way to solve this is to find the common denominator. We look at our problem, 2 3/5 and 2 7/10. We notice that our integers are the same. So they're both 2. We have 2 whole numbers in each of our mixed number fractions. So we can ignore that part and we just need to look at our fraction part. We have 3/5 and 7/10. I need to find the common denominator. I know that both 5 and 10 are multiples of 5. I know that 5 multiplied by 2 creates 10. So I'm going to create tenths. So I'm going to turn my 3/5 into tenths. I'll do that by multiplying both the denominator and the numerator by 2. 5 times 2 is 10. 3 times 2 is 6. So I've now created my tenths. I'm going to rewrite my problem. 5 and 6 tenths and 2 and 7 tenths. My integers, my whole numbers are the same. My denominators are the same, so I just look at my numerators. I know that 7 is a bigger number than 6, so I can say that 2 6/10 is less than 2 7/10, and I can complete the problem. For today's lesson, I would like you to complete the problems which you will find on the PowerPoint. There is additionally a set of challenge questions which you can look at as well if you wish. The answers are also attached to the same PowerPoint at the very end of the PowerPoint. Best of luck today, guys.